Sure. Not with Camtasia. Okay, I think I'm recording. I don't know. Did anybody watch the recording from last week? I didn't.
I did.
Oh, cool. Was it any good?
Yeah, I heard words. I listened to it.
Yeah. Well, it kind of freaked me out because when I went into process it, well, it processed, and when I went to post it into YouTube, I wanted to listen to it first, make sure that there was sound, and I got absolutely nothing, no sound. And there was another record. It gave me an audio only and a recording, and I tried the audio only, nothing. So, oh great, okay, so I'll just post the one from last semester, and that'll give at least something for the students who didn't show up. And then that's when I realized that my laptop was still hooked up to my Bluetooth that wasn't plugged into my ears. So when I disconnected the Bluetooth, hey, I had sound. So yay. Okay. So are there any questions so far on chapter 2 or anything that you found in doing chapter 3 homeworks that you would like to have answered? I know, David, you had some that we've covered. One of those I will, was that you? No, I think that was somebody else I went that with today. I tell you, my days blend in so much that I can't tell whether I'm coming, going, been, gone. To what I'm doing. So anyway, so any questions? What's a wall? What's a wall? What's a wall? I know what a gazinda is. You know what a gazinda is, right? It's like a key. It goes into the hole so that you can open the lock. So any questions so far? Nothing.
I do have some questions. Let me pull it up real quick though. I want to make sure I read what the book is telling me first.
Okay. Well, while you're looking that up, I will cover one of the questions that's been asked by 2 students so far this week on assignment number 2. And it has to deal with problem number 316, which wants you to determine that the maximum distance from a projectile is when the angle theta is at 45 degrees. And then problem 321, I believe, where it wants you to create a random vector of temperatures, and then it wants you to determine the time at max and min. And it's like, okay, how do I do that? And so I will show you how that's done by working through problem 316, because that's the easiest problem to work. I like easy. So I am opening up my textbook. Whoa, hey, you don't need to be making noise. You shouldn't even be turned on. Sorry, my work computer's screaming at me. So problem 316 states that the range of an object shot at an angle theta with respect to the axis, x-axis, at an initial velocity of v naught is given by the range as v naught squared divided by gravity times the sine of 2 times the angle. For 0 to the theta to 2 pi over 2, neglecting air resistance, using g as 9.81 meters per second squared and an initial velocity of 100 metrics per second, show that the maximum range is obtained at approximately pi over 4 by computing the range in increments of pi over 100 between 0 and 2 pi. You'll be able to find an exact angle that results in the maximum range because your calculations are evenly spaced at 100 radian. Okay, so first thing we got to do, script file. We'll do this in a script file. So we're going to create our velocity. So our v naught is equal to, I believe it was 100. And I personally like to put my units as a comment, just so that when, for me, I mean, I can hide my own Easter eggs. So coming back tomorrow, I'd probably forget what the units were. But if you're coming back 5 or 6 months from now and you're looking at this and say v naught, well, what's that? meters per second, feet, miles per hour, what is it? So by putting your units in here, it'll help you when you come back to do some debugging. Okay, so theta is going to equal from 0 to pi divided by 100, right? Up to a total of pi divided by twice. Okay, so there's our, and then obviously this is going to be in radians. Okay, so now we've established our variables. Oh, we got to have G. G is equal to 8.91. It's a good thing I typed it right, even though I said it wrong. I was waiting for somebody to say, hey, that's not right. And this is meters per, velocity is not meters per second squared, that's just meters per second, you idiot. I know that, I was just seeing if you're paying attention. I am, I caught it. Okay. Now I think we got everything entered. So now we're going to do our equation, which is our range is equal to, okay, so V is a scalar, so we don't have to do an element operator to square it. G is an element, so we don't need an element to divide it. And then we're going to multiply it by the sine of 2 times theta. And theta is in radians, so we don't need to convert that to radians from degrees. Okay, and this should come out in meters. Okay, so now we have a, let's go ahead and show this. We have R. Okay, we have values for R for range going from 0, which you expect it to come back down to 0, and starting at 0. And somewhere in here, the maximum range looks like it's right there, 1.0194. Okay, so now how do we find the angle theta? And this works for time vectored equations, any kind of situation where you're searching for the value in one vector that is related to somehow to another vector, be it time, angles, whatever it is. So if we take and we assign a single variable to the output of the max function, the min function, just about any of these statistical functions, if you assign the output from that function to a single variable, it will return the maximum value in that vector. Now, if it's a matrix, if range happened to be a matrix, if there were 2 columns, 3 columns, 4 columns, and multiple rows, it will return a vector of the maximum for each column. Okay, play with it, get to and that's going to become an issue on one of these upcoming assignments. But we'll get to that anyway. Okay, so now we know what the maximum value now, but we still don't know what time or what angle that maximum occurred. So the beauty thing about MATLAB is if you assign the output from the max to 2 variables, the second variable will contain the location within your input range of your input variable. It'll give you the location where that value is found. So this isn't the time, this isn't the angle, this is the location in this vector. So now if we run that, we see that the location is at the 26th element. Well, what do we do with that? Okay, one thing a lot of students will do with that is they'll multiply it and divide it and add things to it to try and get it to get the answer that they're looking for. But that's so hard. There's an easier way. So theta at max R is easily found by going back to your theta variable and find out what's in the same location. and this will give you the answer in radians. So this maximum value is located at the 26th element. The 26th element of theta is 0.7854. And just so we can see how close we are to pi over 4, if we divide that, we can see that's an exact match. Okay. Any questions on that? No?
Actually,
Anybody?
one question, Arthur. How are you getting your units to come out like that? I have
unit?
like, well, I mean the answer is still correct, but I'm getting like 7.8540 e to the negative 0.1.
Do a format short.
Short.
Yeah, and spell it right. Format short. Hit enter,
Okay.
and then rerun your code. And does that do it more gooder?
Yeah.
Okay. Yeah. If you'll look up here, you'll notice on my, this is a shortcut that I made. That's for when students change the format, because you can change the format output so that it's always scientific notation, or if it's fractions or whatever you want. I like format short because it gives me 4 digits and I can see what it, so I have that so that when students change it, I can change it back real easy. Okay. Did anybody learn anything here, or did y'all know that already?
I definitely didn't know that.
Okay. Okay, so this was actually something that I was going to cover today, so yay. So I expect at least you 3 to get problem 316 correct. Okay, another thing I want to cover today is trig functions. Just the only thing I need to say about it is be aware, or be aware. Just be mindful that the input to your trig functions are in radians, not degrees. Okay, so the sine of pi of 180 is supposed to be 1. So this is 180 radians, which brings it out to there. Now, if there is, there's several ways that you can do this. If your theta is given to you in, okay, let's say it's 53.98 degrees. Okay, there's 2 ways that you can convert that. We'll do theta 1 is going to be, you can take theta and multiply it by pi and divide it by 180. That'll give you a conversion to radians. The other way is, I believe it is theta, here we go, degrees to radians of theta. And we don't want, let's do theta 2 here. So theta 2 should equal theta 1. So, and then if you take the sine of those, you'll get the actual value. So just remember that the inputs to your trig functions are in radians, not degrees. Okay, so I guess maybe this is some more statistical. Oh, and here's something that I think you did this, David, and then when you first sent me a screenshot yesterday, and I looked at it and said, "Ooh, I got to talk to him about that." And then when you sent me an updated one, you fixed it. But just be careful when you're assigning variables. Don't use variable names as a variable, because you just rewrote that function to a variable. So if you come down here after you've done that, and now you want to find what the mean of P is, it's not going to work because it's no longer a mean function. It's a variable that has the value of whatever the mean of Y was. I'm sorry if I put you on the spot there, David. I commend you because you did fix it on your own without me telling you. So
Yeah, it's fine.
so and if we have P equals a bunch of random numbers, so this should give me an error because P, the mean now is a variable instead of a function. And so it just there's only one value in mean, which is 16.166. So I can't do that. So if you want to use that, you need to maybe just capitalize the first letter or make it somehow different. So now the mean is a variable because that's capitalized and the function still exists. Okay. So again, like I said a little bit earlier, if you have a let's make this matrix 1, 2, 3, 1, 2, 3. Put one of those in there, and I mean it doesn't have to be square, but okay. So now let's just comment this guy out. We don't need you. We don't need you. So oh, and if you're curious, I just commented that out by hitting Control R. Whatever you highlight will comment out. If you hit Control R, Control T undoes it. I have a lot of keyboard shortcuts, so if you don't see me doing something that you're wondering how does he do that, holler at me. I'm more than happy to share my vast knowledge over the years. Okay, so now Y is a vector. So if we look at it, it's a 3 by 3 vector. So now if we take the mean, this is going to return a vector of 3 values. So this is the mean or the average of the first column. This is the average of the second column, and this is the average of the third column. Okay. So if you wanted to find the average of the whole thing, one way to do that is to nest do a mean, which, oh, sorry. So now this is an average of all of these numbers, okay? Now there is one statistical function that this does not work on, and I can prove it to you here, okay? That would be the STD, the standard deviation. So if we do the STD of Y, it's, again, this will return, let's make this equal to a variable here. So this is a standard deviation of the first column, the standard deviation of the second column, and this is the third. Now, a lot of students will say, okay, so to get the standard deviation of the entire matrix, we'll just do another STD on, oh, not a plus sign, you idiot. STD on the STD. Okay, it returns a single value. But what this value is the standard deviation of these 3 numbers and no longer this. And I can prove that because if we do, because there is a problem coming up, I want you to find the standard deviation of the matrix given to you. What you need to do is turn your matrix into a single column vector. How do you do that? I'm about to show you that. Just hang on a second. So we're going to find the STD of Y, but if we do a colon inside of parentheses in front of that matrix call, that turns that, well, here, I can show you. So if we look at Y here, it's a 3 by 3. And if we come down here and just grab that, will now see that y is a 1 by 9. And so now it'll find the standard deviation of that. So now if we look at here, see this number is not the same as that number. So you do have to be careful when you're doing nested statistical calls functions. It works on the mean because, you know, it's just taking the average of the average, but not so much for the standard deviation. Hey, that was clear as mud. Thanks for your help. Okay. Any questions? Okay, this could be a short meeting if you guys don't have any questions.
I have a different question.
Okay, I do different questions and I give totally random answers.
So 1 second. Let me pull it up on my MATLAB so I can see what my question was.
Do you want to share your screen?
Well, I can just kind of explain it.
Okay.
So for number 24.
Oh, that's the Excel file.
Yeah.
Did you get it loaded into MATLAB?
So I got it loaded into MATLAB. I did the import data, and then I changed it to the save each column as a vector. And then, so for problem 24B, it
Okay.
asked me to find the average monthly mean minimum temperature, which in the book it shows as MMNT, but then B says use the MMXT column. And so I'm curious whether or not that is a typo or is that
Oh, it's
actually
possible. I think Holly's on drugs when she wrote this chapter. I mean, Holly was having. I don't envy the textbook writers to have to come up with all these questions. So find the average month of 215 MMXT. Okay. So MMXT is the third from the right. And you're saying what, the data file had a different?
No, so underneath the table in the book, the monthly mean minimum temperature is MMNT.
Oh, okay.
It makes more sense that it's a typo as opposed to it's actually supposed to be like that, but I'm not sure.
Yeah, I will accept either column.
I just ended up putting in both to play it on the safe side.
There you go. Better to do too much than not enough. Okay, yeah, so monthly minimum should have been based off of the data above A. MMMT is the monthly mean minimum temperature, whereas the MMXT is the maximum temperature. So yeah, it's a typo. It's about time for Holly to come out with a new book anyway. This book is old. When was this thing come out? I mean, we've been using it for a long time. I know they changed my SolidWorks book every it seems like every semester, but 2018. this book's 3 years old. Yeah, well, it looks like she's been every 3 years. So about time for a new book.
And actually, Arthur, another question I had is, so when doing this problem, we download the data for the Excel file from Canvas. We import the file and save each column as a vector, and then it shows up in my workspace. If I press clear, does that get rid of that file?
If you push, yeah, yeah. So it should, and then if you need to use it again, you have to reload the data file.
So before we turn this in, we have to make sure that we don't like clear the workspace or anything like that, because otherwise it'll show up as not having any data.
No, when I get it, it won't have anything. I'll have to load the data in. But
Okay.
this problem, I'm very flexible on because it is. I mean, it seems to me like she just threw that Excel problem in without really explaining in the textbook how to deal with Excel files. And so I'm you know, I go easy on that problem. And I'm actually a very lenient grader too, so.
And would you be willing to go over problem number 21?
Problem
That's
21.
Yeah,
Is that the temperature one?
I believe so. The one where you have to plot as well.
Yeah, well, plot's easy. In fact, it tells you in the book how to do the plot.
Yeah.
I also had a hard time with that because I didn't seem to be getting like an organized I wasn't getting organized coordinates from what I could tell. It was kind of all clustered together, and
Okay.
it looked more like how like a sound wave looks like digitized.
Digitized.
It looked more like a wave than actually plotting like points, but I'm not sure if that was me doing that incorrectly.
Yeah, no, it's not a problem. For a price, I won't mind doing it for you guys. Oh, that was rude. I know. I do that sometimes. Sorry. Okay. Yeah, sure. No problem. So in this problem, 321, suppose you're designing a container to ship sensitive medical materials between hospitals, yada, 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 yada. Okay, so we want to create a normal distribution, a Gaussian distribution of temperatures with a mean of 70 degrees Fahrenheit and a standard deviation of 2 degrees corresponding to a 2-hour duration. That is a lot of information for such a simple problem. Okay, so first off, we need to make our temperature. So we'll just call it temp. And it says to do a normal distribution of random numbers. So that's going to be a rand n. And it says it wants one random temperature. So okay, so 241 values, right? You'll need a temperature for each time value from 0 to 120 minutes at half-minute intervals. That's 241. So now just make sure you guys understand that the inputs to the random function generator, if you input only a single value, it will create a square matrix with that dimension. So if I enter a 5, this will create a 5 by 5 matrix, 5 columns, 5 rows, but that's not what I want. I want to have one row, or okay, let's do, yeah, it don't matter. Let's do 241 rows and one column. Okay, so I'd say every function that has matrix input ability, the first value will always be the number of rows it creates, and the second one, the number of columns. So if I wanted to have one column and 241 rows, sorry, one row and 241 columns, I would enter it that way. For this, it really doesn't matter. So that just created 241 random numbers. We can see it's random by just looking at this last value, 3271, 1903. So we can see it's changing. Okay. So that gives us our randomness, but now we need to do our standard deviation. So to get standard deviation off of this normal distribution, we multiply it by our standard deviation. And then to get the mean value, we add the mean that we're looking for. So here is my temperature, and you'll see that it's fairly consistent around the degrees, you know, the specifications that I requested. Okay, any questions on that part of it? Okay, so that was the easy part of the test, or the problem. Okay, so plot, so we'll do a plot. Okay, we need to have a time vector, and we're going to go from, oops, time equals, we're going to go from 0, 0, 0. Yeah, I think it was 0. And we want half minute intervals, 0.5 to 120. So we see here that we got 241 there, and we should have 241 there. So we now, or we could have easily just come over here to our workspace and see that they're both the same size. So now that they're both the same size, we can just do a plot of time on the x-axis and temperature on the y-axis, and voila, voila, there it is. There's our temperature plot. And as you'll notice, every time you hit enter or rerun that cell, it's going to change. And then we just use the same feature that I did up here for finding the time at max and min. So I'll, you know, we'll say, oops, not that button, this button, max temp and location is going to be max of temp. And time at max equals our time at the location of the maximum value. And there we go. The time at max was at 71. So if we come in here to 71, this is going to be 71 right there, 71. Wow, look at that. Is he good or what? Don't answer that. 93 and a half. So right here, this one's 93 and a half. Okay, any questions? Or should I say, did that answer your questions?
Yeah, that answered my question. I was just curious whether or not we did it, the part C as well, similarly to what we did earlier.
Yeah. You know, there are a lot of ways that students try to get around doing it that way, but to me, this is the easiest way to do it. You know, some of them would do a sort on temp. Okay, and so this tells you, okay, well, here's the largest value, but it doesn't tell me where it's located. There are ways to find that. but we haven't learned it yet. Again, this we're going to mess this whole thing together here and see how badly it screams at me. So this is the time here. And so this is a function you'll learn in a few chapters. It's called the find. It goes through this matrix looking for this condition. So I'm telling it to find the temp, the maximum temp, and then go in there and find it, and then find the location into the time. What did he do? That was crazy. Did that answer your question, Athena?
Yes, it did. I was doing it wrong.
Oh, I'm sorry. What was you bidding?
I think, um,
Okay, one thing that a lot of students do here is they'll just put in 241, and then that gives
yeah,
you the,
that's what I did, and that's what I got.
yeah. So help to just do one of it. So basically, what you've got is, whoa, that's going to go forever. Remember Control C. Oh, this works because you have 241 random lines. There are just so many of them there, you can't differentiate one from the other. But this is more what we're looking for. Jordan, you're awful quiet. You still here, or did you go to sleep? He must have went to sleep. I'm putting him to sleep, killing them off. Okay, there was something that came up after the end of the last session last week that I'd forgotten to tell you guys. Do any of you remember what it was? Because I forgot. I don't. I guess maybe if I remember today, I'll write it down and we'll get it to you next week. The exams have been scheduled at the testing center. I know what it was. That's a good thing I said that. Testing center. In the past, prior just the few semesters before the world ended in 2020, the testing center would give you an electronic copy of the textbook to use during the exam. We had to resort to this because some students would spend hours upon hours writing all kinds of crib notes and whatnot in their textbooks. And it just got to the point where it was so bad that we couldn't allow textbooks into the testing center. So we gave them an electronic copy. I did get an email from the testing center earlier this week asking if we were going to give them an electronic copy again. And when I inquired to those who I report to about it, they says, well, they should have one. So I need to find out. So in the off chance that they do not have an electronic copy of the textbook, if you want to take your textbook into the testing center with you, you cannot have written in your textbook. So short story long, don't write in your textbook if you want to take it on with you into the test. If you have an electronic copy, I'll have to find out what we can do about that because they don't like other electronic devices coming in that they can't control. So I'll have to find out about that. I know in the past for students, I have taken my textbook over to the Redwood campus so that they could use my textbook. I don't know, I guess, I don't even know where, is testing center in the Redwood campus where it used to be over in the construction trades building? or did they
Um,
move it?
As of spring semester 2020, it was there because I had to take a placement test there.
Ah, see, I used to teach a class in the wood shop just above there. We built electric guitars, so I'm familiar with where that. So I guess I'll find out from Connor. So I'll look into that and let y'all know before the exam comes up, which is coming up probably quicker than you guys want it to. When is the exam? Oh, it's sitting right here. The first exam is June 16th and 17th.
So it's going to be open book, just not open notes, right?
Correct. You can take your textbook in, but no notes, no old homework, no friends, no psychic abilities, no internet. You can use the help features in MATLAB here. You know, type in help plot. You can use these functions, just nothing else.